Hi Year 12s. This is our first video in the series on functions and graphs. In the final exams, you will need to know how to draw the different types of functions, whether it's a power, polynomial, circular, exponential, logarithmic, hybrid, or composite function. This video will focus on integer power functions, where the power is either a positive or negative whole number. First, we will look at a power function with a positive number. This power function is when we have any variable x to the power of any non-zero positive integer, represented here as n. Some examples of this would be x squared, x cubed, or x to the power of 4. The basic shape of x to the power of an even number is a U shape. This we can see in x to the power of 2 and x to the power of 4. The basic shape of x to the power of an odd number is close to an S shape, and we can see this in x to the power of 3. They are fairly straightforward to draw, as we know that 0 to the power of any positive number will always be 0. So the graph will always travel through the origin. They will also always equal 1 when x equals 1. As we can also see from the graph, for any odd powers, when x equals -1, the y-point on the graph will equal -1. And for even powers, when x equals -1 on the graph will equal 1. Any other point can also be easily calculated with substitution. Let's look at graphs where x is to the power of an even number. As n increases, the graph appears steeper. Therefore, as n increases, the value of y on the graph goes up. However, this is not true when x is between 1 and -1. In this area, as n increases, y decreases. For odd values of n, the graph again appears steeper as n increases. When x is positive, it follows the pattern that we just described for when n is even. That is, when x is above 1, as n increases, the value of y on the graph increases. When x is less than 1, but greater than 0, the value of y decreases as the values of n increase. When x is between 0 and -1, the value of y is actually greater when n is smaller, since the function now gives a negative value. When x is less than -1, the value of y will decrease the lower the value of n. We will talk more about these graphs when we introduce polynomials. The second type of power function is an inverse function, where we have x to the power of any negative integer, or 1 over x to the power of any positive integer. This is a far less intuitive graph to draw, so let's look at some examples, such as x to the power of -1 and x to the power of -2. In these graphs, when x equals 1, y will also equal 1. As we can see from the graph, for any odd powers, when x equals -1, the graph will equal -1. And for even powers, when x equals -1, the graph will equal 1. Any other point can also be easily calculated through substitution. As you can see from the graphs above, they both edge closer and closer to 0 on the x and y axis, but they will never reach it. This is called an asymptote, and the horizontal asymptote is located at y equals 0. This is because, as x approaches positive infinity, the function will become smaller and smaller, but it will never actually equal 0. As x approaches negative infinity, the function will also become smaller and smaller, but it will never equal 0, this time going from the negative direction. When n is an even number, we see the same situation occurring, with the same asymptotes. There is no answer to any value of x divided by 0. So, in addition to a horizontal asymptote, we have a vertical asymptote at x equals 0. For when n is an even number, we see the same situation occurring. The domain of both these functions is any number except 0, which can be written as r'0. This just means that x can be any value except 0, since we can't divide by 0. So, how would we go about drawing a function, such as 1 over x to the power of 3? Straight away, we can identify it as a negative odd number, so we know it will have a similar pattern to 1 over x to the power of 1. Therefore, it will have a horizontal asymptote at y equals 0. We know there is no value for x equals 0, so there will be a vertical asymptote here. We also know that it will pass through the points of x equals 1 and y equals 1, as all the negative integer power functions do, and that it passes through x equals -1 and y equals -1, as it is to the power of an odd number. Following these universal power function rules, we get this graph. However, the drawback to having these universal rules is that when we draw this graph by hand, it could be any x to the power of a negative odd number. To show we've drawn the correct graph, it's important to label another random point, like so. This shows it is a unique graph, 1 over x to the power of 3. It's important to master these basics, as soon they will be more complicated once we start transforming them. Happy studying!